Good morning all of you, and today we will discuss about to the next topic, that is called the virtualization, and it is basically belongs to the unit 2, and this is a very important topic about to cloud computing. Without this virtualization we cannot imagine the cloud computing. So let's start with the first, what is virtual machine. So virtual machine means we can say that that is not available physically, but they are available in virtually. So that's why it's called the virtual machine. In the virtual machine, a software implementation of a machine computer that execute program like a physical machine, just like in your program. For example, if you using the Google Colab, and you will just select the GPU or CPU, etc, etc, so you can easily access this machine by using just subscribe, or there are some free of cost are there also given. So virtual machine provide an interface identical to the underlying bare hardware. Already they have a hardware in your hardware. So they provide the interface to access the another machine. So the operating system create the illusion of multiple process. That is not a real process, but it create for the multiple process, each executing its own processor with its own virtual memory. Okay, so that is the basic fundamental idea about the virtual machine. So after that virtual machine, you know very well about that virtual machine, that the virtualization. So virtualization, like there are some apps, that is the virtual machine, and that is the server, and this is the physical server. So you can access this physical server with this virtual machine. In the virtual machine you have a OS and you have a application in that particular OS. So virtualization, one of the hardware reducing, cost saving and energy saving technology that is rapidly transforming the IT landscape and fundamentally changing the way that people compute. With VMware virtualization solution, you can reduce IT cost while increasing the efficiency, utilization and flexibility of their existing computer hardware. So with virtualization, it is possible to run multiple operating system and multiple application on the same server at the same time, increasing the utilization and flexibility of hardware. For example, here there are the virtual machine and there are the different OS are there, OS 1, OS 2 and OS 3. There is only one physical server, but in this physical server using virtual machine you have run 3 OS with these 3 applications. So there are some histories about to virtual machine virtualization. First appeared in IBM mainframe in 1972, that allowed multiple users to share a batch oriented system. Okay, formal definition of virtualization help move it beyond IBM. A VMM, virtual machine monitor, VMM is called the virtual machine monitor, provide an environment for program that is essentially identical to the virtual original machine, like same physical machine. Program running within that environment show only minor performance decreases. The VMM is in complete control of system resources. In late 90, Intel CPU fast enough for research to try virtualization on general purpose PC. Like Zen and VMware created technology still used today. Virtualization has expanded to many OS like guest OS, many CPUs, different CPUs, and many virtual machine monitor like a hypervisor. VMware, that is called the modern virtual machine system, that is funded 1998 Mendel Rosenwald researcher at the Stanford University. VMware Workstation separate host OS from the virtualization layer. Host OS may be Windows, Linux, etc. and wide variety of the guest operating system. Okay. So basically, what is virtualization? That already we known about that the previous things are there. So virtualization, that is like we have to virtualize the machine. So giving an illusion that each OS is running on the real hardware. So virtual machine monitor VMM, another layer of kernel to virtualize multiple OS, also called hypervisor, that is also called VMM. And OS as a supervisor is no more hardware detector. So here is the hardware. This hardware is connected to VMM, and this VMM create three different type of OS, like first Windows, second Linux, and third Mac. Is also we can using the Android, fourth. Okay. So that is the working of this VMM is connected with the hardware as well as connected with the different OS. So popular virtual machine like VMware Workstation, like Xen, like VirtualBox, like Citrix, and like KVM. So what say goodbye and what say hello? Software developing, goodbye. Application monitoring, goodbye. Server management, goodbye. Network management, goodbye. Security management, goodbye. Data management, and too many carbon dioxide. Software developing, we can using a one software as a service using cloud. Platform as a service, we can easily using application in the platform as a service. Server, network, that is also infra as a service, data as a service, IT as a service, or that is basically belongs to the green IT. That green IT is belongs to, there is no emission, there is a limited emission of the carbon dioxide. So what are the structure of the virtualization? Structure in the virtualization, tools and mechanism. In general, there are three typical class of VM architecture. That figure show the architecture of the machine before and after virtualization. So we can say that before virtualization, the OS manage the hardware. OS manage the hardware. After virtualization, a virtualization layer is inserted between the hardware and the OS. Like this, that is the hardware, that is VMM, and that is OS. So this is between the hardware and OS. Hardware and the OS, in such cases, the virtualization layer is responsible for converting portion of the real hardware into virtual hardware. So this create the virtual hardware. Okay. Therefore, different OS such as Linux and Windows can run on same physical machine simultaneously depending on the position of the virtualization layer. There are several classes of VM architecture, namely the hypervisor architecture, para-virtualization, and the host-based virtualization. The hypervisor is also known as VMM, virtual machine monitor. They perform the same virtualization OS. So before virtualization, in the before virtualization, there is some applications are there. There are the OS, there are the x86 architecture like a hardware. There are the different CPU, different memory, different NIC card, different disk are there. So single OS image per machine, one OS, one machine. Software and the hardware tightly coupled are there. They are tightly coupled. Running multiple application on same machine often create the conflict, and also inflexible and costly infrastructure. So that is the scenarios of the before virtualization. But after virtualization, there is a hardware, same architecture, but in this between there are the VM virtualization layer. So this VM virtualization layer create the virtual hardware, and they are the virtual OS that called the guest OS, and this guest OS running the application. So we can run a single hardware, two different type of OS. Okay. So hardware dependence of OS and application. Virtual machine can be provisional to any system, can manage OS and application as a single unit by encapsulation then into virtual machine. So what are the importance of the virtualization in the cloud computing? So that is very important of the virtualization, because this virtualization is create the virtual machine, and then virtual machine create the OS, and then different hardware are virtualized. According to Intel, here are the differences. Virtualization abstract compute resources typically as a virtual machine with associate storage, networking connectivity. The cloud determines how those virtualized resources are allocated, delivered and presented. Virtualization is not necessary to create a cloud environment, but it enables rapid scaling of resources in a way that non-virtualized environment find hard to achieve. So we do virtualization. So VM share the centralized server process, memory and storage. Earlier 800 million Unix server is working, but now with VM only 60 million server is doing the same work of 800 million server. So that is the ratio. First they are using the 800 million, but now the same thing are using the only 60 million server. Okay, like this, they are the wasted resources that is not used. So also that is using for the green focus, like 800 million server or 60 million server emission carbon dioxide is very maximized. So most server only use 5 to 15% of their capability on the average, while consuming 60 to 90% of their peak power. The solution, virtualization. They use one server to host multiple applications, reduce energy consumption or reduce CO2 emission. Running fewer highly utilized server, free up space, power. Less space, power is better for environment and the save money and environment also. So that is the models: hardware, kernel, process. That is the non-virtual machine. But in virtual machine, there is the hardware, there is virtual machine manager or monitor, that is also called the hypervisor. That is VM1, VM2, VM3 is create the kernel, or that is create the process or OS. So that is the environment of the virtual machine. So architecture is isolated runtime environment, guest OS and application. So here is a physical box that is called the virtual machine. They are the virtualization platform, Zen, KVM and VMware. They have created the N virtual machine, VM1, VM2, VMN, and these are the some guest OS. VM1 have a guest OS 1, guest OS 2, guest OS 3, N. Okay. So what are the definition using in this VM virtualization? Host operating system. The host operating system is a operating system that actually running on the hardware, like your hardware. If you are the server manager, if you are the data center manager, if you are the cloud administrator, so that OS is called the HOS. Together with virtualization layer, it simulate environment for guest OS, that OS which is if the consumer used, okay, client use. So guest operating system running in the simulated environment, the one way we are trying to debug. Like this, they are the hardware, CPU, memory, IO devices. That is host operating system into the hardware, that is called the Linux. If using the virtualization layer, so guest operating system, guest operating system, guest operating system, they are using the BSD, they are using the NT, they are using the XP and etc. And these are the some application which is directly connected to the Linux. So that is the architecture of VMware. So how does virtualization work? A virtualization layer is installed. Use bare metal or hosted hypervisor architecture. A bare metal hypervisor system does not require OS. Hypervisor is OS. So hardware that is connected the hypervisor, or we can say that the VMM, that is OS1, OS2, etc. In OS1 there are the different applications. In OS2 there are the different applications. So hypervisor, already go to about that. That is VMM, piece of computer software, firmware, hardware that create to run virtual machine. A computer on which a hypervisor running on one or more virtual machine is defined as a host machine. Each virtual machine is called the guest machine. So hypervisor is bare metal approach, is installed on the bare metal, and the OS is installed, that is called the para virtualized. There are the two type of hypervisor, type 1 and type 2. Type 1 hypervisor interact directly with the hardware that being virtualized. It is completely independent from the OS. Boot before the OS, they are often referred to native or bare metal or embedded hypervisor in the vendor machine. Type 2 is on the top of an OS, relies heavily on the OS. It cannot boot until the OS system is already up and running. If OS crashes, all end up affected. Type 2 hypervisor depend on the OS. They are not full control of the user machine. Like this, for example, that is hardware, that is hypervisor, that is OS 1, 2, 3, etc., etc. That is the bare metal hypervisor, or we can say the type 1 hardware. That is type 2 hardware, OS 1, that is called the host. These are the guest. So type 2 hypervisor is connected with the different OS. So what is the difference between both of them? Depending on what sit right on the hardware. Type 1 VMM on hardware, type 2 host OS on the hardware. Okay. What is KVM hypervisor? KVM hypervisor is known as kernel based virtual machine. Is a virtualization infrastructure for the Linux kernel which turned it to the hypervisor and allow its host OS to act as a type 1 hypervisor. However, as Linux distribution is OS is its own right, one can argue that KVM is type 2 hypervisor. Like this, that is x86 environment, that is KVM, included into the Linux. That KVM create the virtual machine. They are virtual machine, and these are the some Linux application which is running on the. Okay. So virtualization architecture, there are basically two types of architecture: hosted architecture or bare metal architecture. Bare metal, already know that type 1 hypervisor or VMM is installed on the bare hardware. VMM communicate directly with system hardware rather than relying on the host OS. That is bare metal virtualization. Application VM, application VM, application VM, that is VMM, that is shared hardware. That is called the VMware hardware, that is directly connected to the hardware. Advantage, improvement IO, support real-time OS. Disadvantage, difficult to install, depend upon the hardware platform. Hosted architecture is first installed, then after software called the hypervisor or virtual machine monitor is installed on the top of the host OS. It allows users to run various guest operating system as their own application, VMware Workstation, Oracle Virtual Machine, Microsoft Virtual PC. That is the hosted. Here hardware, in this there is between host OS and then virtual machine, and these are the guest OS. Host based virtualization require operating system. We already know that virtualization layer installed in the application on the OS. Like VMware server is free application supported by the Windows or Linux. Advantage, easy of installation, unmodified, run on a wide variety of PC. Disadvantage, performance degradation or lack of support for the real-time OS. These are the some references which are using in this PPT, and if you have any query, just ask me in my mail ID gupta.pradeep@akgc.ac.in. Thank you.